Welcome to SanfordFlipMath. This is Algebra 2. We are working through the Springboard curriculum. We are in Activity 7.2, which is about factoring of quadratics, deep in the heart of quadratics chapter. And again, this is kind of a recap. We've done most of this in class, but we just want to have this available so that students can pop back and get more information. We are heavily invested in an area model for multiplication. Now what that means is we are thinking of multiplication like length times width. And so this picture is the idea that, here we have x plus 2 times x plus 1. And really all we're doing is using area as a way to picture what's going on to help us understand that multiplication can be thought of in parts, because x plus 2 times x plus 1 is a little bit complicated. There are a lot of things actually being multiplied. Now, most of you are very familiar with FOIL, the idea of first, outer, inner, last, as a way to kind of keep track of multiplying two binomials. X plus 2 is a binomial, x plus 1 is a binomial. They both have two terms. And so when I multiply this, I have first times first would be x squared. And the idea is that coordinates to this box, x times x, its area would be x squared. Similarly, if I do outer, well, outer is going to be this x times this 1. And x times 1 is 1x. And that could correspond to this box. Oh, no, sorry. That was kind of silly, wasn't it? So 1 times x would be this box, 1x. And so here, so far we've done x times x plus 1, this entire box. And then continuing on, inner would be 2 times x. And that corresponds to this box. And then last times last would be the 2 times 1, and that corresponds to this box. And if we combine all of that, that'd be x squared plus 3x plus 2. Okay, well, we're not using the box to multiply so much, but if this were an Algebra 1 class, we would be all over that. It's just to help us picture what's going on. Okay, well, factoring, which is what this video is really about, is about unmultiplying, about taking apart the multiplication. Guess I didn't really need to write that. Most of you know what factoring is about. Okay, so really what we're trying to do is say, where did this come from? And we're going to talk about a process. Now, there are many processes for many different approaches for how to take apart this multiplication. Many people just use kind of a guess and check kind of approach, which is awesome. I've been doing that for years. But the idea here is if we could be just a little bit more step by step about it, then it would take some of the mystery out of the factoring. So that's what we're going to do. All right, so here's the plan. This x squared, we're going to put it right there. The 2, we're going to put down here in the lower right-hand corner. So this is from the pieces of what's here, we're going to put those there. That's just going to be the automatic. So this is the ax squared, this is the c, every time. Okay, and when we're thinking ax squared plus bx plus c. So the hard part is, where does the b come from? Well, that middle term is the trifling one. It is the one that is difficult. It's the one that's always the mystery term, because it's like, okay, well, and the problem is that it's hidden because that's after two things have been combined. And usually those two things are outer and inner. And so what we're going to do is be very step by step about this. We're going to look at the factors of a times c. A is the number in front of x squared. And so right now, that's just 1 times 2, or in other words, 2. Well, there aren't very many factors of 2. There's 1 and 2, and 2 and 1. Well, that's not really distinct, so I'm not even going to list those separately. And then the other consideration is, okay, let me clean this up a little bit. The other consideration is the signs, the positive or negative issue. Okay, so let's talk just for a minute about positive and negative signs. If this sign is plus, that means last times last had to either be a positive times a positive or a negative times a negative. So positive times a positive is positive, a negative times a negative is positive. Okay? If they are, so in other words, the same. If they are the same, then this sign will dictate which one it is. So this is going to be a positive times a positive. So my only possibility for this particular problem is a positive 1 times a positive 2, which happen to add up to 1 plus 2 is 3. What I am looking for is for that middle term to match there it is. It's the sum, and that the hope is that that sum is going to be whatever b is. Okay, so what that tells us then, these two numbers go over here. Okay, so this is going to be 1x, because this is where the middle terms came from, and this is the other one's going to be 2x. Now, which one goes where? It doesn't matter. Okay, so we are going through the process of how we do this, and we'll do some more examples after this. Okay, so now what we're going to do is look at this and try and figure out what the dimensions were. Okay, so I'm going to look at these two and say, what's the common factor? What's the thing that was multiplied in each of these? Well, this one's x times x. This one's 2 times x. Both of those have x. In these two, I don't see anything in common. I see a 1 times x. I see a 1 times 2. I guess there's a 1 in common. Okay, now going sideways, same idea. What's the common factor in x times x and 1 times x? X. What's the common factor in 2 times x and 2? I guess that's 2. So what I'm looking at here is this is x plus 2. This is x plus 1. So all I do is put those together, and I have just factored it. Okay, now, most of you are really on to me by now, but I just did the same problem frontwards and backwards. Now, I don't want you to get all worried about it, but it's probably worth noting that these two, because I was doing the problem not thinking about where it came from, actually switched places, and that's fine. Okay, and also worth noting that if I would have written x plus 1 times x plus 2, that would have been awesome also. Same thing, multiplication is commutative. If you change the order, it doesn't change the answer. Okay, all right, so hit pause if you want to stare at that for a minute. We're moving on to the next screen. Okay, so this is what the problem is going to look like. All it's going to say is this. Okay, now let me say that there's nothing magical about the box. I happen to love the box, which also called the area box or area model. I love the box just because it takes the mystery out of what's going on, but all the problem's really going to say is factor completely. If you already are very comfortable with factoring and maybe you use a different method, there are different note-taking organizational schemes to do this, graphic organizers. That's really all this is, a graphic organizer. If you do some other method, Happy New Year. That is awesome. It doesn't matter to me, as long as you know how to factor. Okay, so here's the plan. Okay, again, take the first term, slap it right there. Take the last term, slap it right there. Okay. Then what you're going to do to know what to do in the other boxes is you're going to work this little table. Now, at some point, you're going to get good at this, and you're going to start seeing what numbers will work in there. Okay. Right now, we're just going to chug through the process. Okay. So factors of a times c. Well, a is 1. C is 32, so this is going to be factors of 32. And I'm going to be, again, very organized about how I do this. I'm going to say 1 times 32, 2 times 16, 3 times, okay, 3 doesn't go into 32. 4 does, though, so 4 times 8, 5 times, nope, 6 times, nope, 7, nope, 8. Okay, so as soon as I get to 8, I'm repeating. Okay, I'm done. Sum, now, before we hit sum, please note that the signs here, this sign is positive, which tells me they have to be the same. If they are the same, then they are that one. Okay, so that really means that all of these little guys are negative. Okay, so let's add them up. This would be negative 33, this would be negative 18, this would be negative 12. Well, what number do we want? We need it to match the middle term. In other words, b. Well, I see b is minus 18x, so it's really this one. So that means I'm going to use these numbers for my other two little sections in the box. It doesn't matter which one you write where, because all we're going to do from here on out is do some factoring. Okay? All right, so common factor here, x. Common factor here is 2. We'll deal with the signage in just a minute. Okay? Common factor on the top row, x. Common factor in the bottom row, 16. Okay, now quick little note here. The rules for the signage here are the same rules for the signage here. Okay, so in other words, if this says plus, they're going to be the same. If this is a minus, then that's what they're going to be. Now let's just double check what's going on. If I do some multiplying, so like x times x is x squared. X times negative 2 is the negative 2x. This sign was negative. It has to work there, okay? All right, same thing in the bottom row. Negative 16 times x, it worked. Negative 16 times negative 2 is positive 32. And we're done. All we have to do now is answer the question. Now, it seems long, but the more you do it, the faster it goes. We're done. We've factored, okay? You can check it, you can FOIL it out, but we kind of did already in that box. All right, again, if you need to stare at this, hit pause, I'm moving. Okay, this one is the one where people, sometimes the previous examples, people say, oh, come on, I can do that. And then this one, we get a number out front here, and people start panicking, okay? This is the real power of using the area model or the box, okay? All right, so again, 2x squared, negative 12, okay? Factors of a times c. Now this is, so 2 times 12 is 24. We're going to write factors of 24. So like 1 times 24. Again, I'm going to go in order. Now some of you are saying, come on, I know how to do this. I got this. I don't need to do all that. Well, okay, don't. Then that's fine. 1 times 24, 2 times 12, 3 times 6, 4 times 6, 5 times, not into 24, nope. 6 times, now we're repeating. Okay. Now let's talk signs before we get too excited here. If this is minus, that means the signs have to be different. The bigger sign, or I'm sorry, this will tell us the sign of the bigger number. Okay, so that means that these guys, the bigger numbers have to be plus, and the smaller numbers have to be minus. So in effect, we are subtracting. So this is 23, this is 10, this is 5, this is 2. Now, that is very interesting. All right, well, I didn't expect this to happen. Apparently I had a righto when I was writing these, but that is okay. I'm kind of happy this came up. What are you seeing what I'm seeing? Okay, I probably should have said plus 5 here, but that is okay. Well, what we've just found out is since, let me just double check the signs, yep, okay, and we're good. All right, good. What I was checking is to make sure my math was right, because really, this thing is prime. In other words, you can't factor it. We have just checked every single possibility by going through this list. We know that this does not factor, okay? So we're done with this problem. I know that was mean, wasn't it? And yes, it could happen. Okay, so let's do one more example. And this one is not so cute. Now, if you notice, all of the directions for these have said factor, but they've said factor completely. What that means is there can be more than one step in the factoring process. There's more than perhaps just 2 factors. Kind of like if you're going to factor 12, you'd say, oh, maybe 2 times 6, and then you have to factor 6 some more. So this is 2 times 3. Yep. So, okay, that was interesting. Okay, magic of recording, 2 times 2 times 3. All right, so the idea was factoring completely, you might have to factor and then factor again. Okay, so let's do this some more. Okay, so what that means is we're going to browse through here and see first, is there something that's in common? Well, I see an x there, I see an x there, I see an x there. So we're actually going to undistribute. We're going to factor out that x first. Okay, so this is going to be 3x squared plus 31x plus 10. Okay, so we factored, but this can be factored more. And so this is the part we have to look at like what we've been doing. Okay, so here we go. We're just going to keep right on going like we've been doing. So 3x squared, 10. We're going to try and find a way to add up to 31, and we're going to look at factors of a times c. So in other words, factors of 30. So 1 times 30, 2 times 15, 3 times 10, 4 times 5 times 6, and then they're going to start repeating. And let's look at signs. So this sign is plus, which tells me they're going to be the same. This sign is plus, which if they are the same, then they're going to be whatever that is. So in other words, they're both going to be positive. So let's add these up. Okay, and which one of these do we like? Well, we like the one that says 31. Well, it turned out that's the first one. Now, if you were paying attention real close, you might have caught that before we wrote all of them. And if you did, then you are the winner. You got it. All right, well, we're getting really close to done. So now look for the common factor here. So it looks like 3x goes into both of those. Here looks like just 1. Going horizontally, I see x and looks like 10. Okay, so this is going to be 3x plus 1 times x plus 10. Okay, and just a reminder that we had an x out in front. Got to bring that bad boy along. It was part of the process. And we're done. Now, if you wanted to confirm this, I would recommend multiplying this out first. You know, if you're just going to check, FOIL that out first, and then take that answer and distribute the x across it. Okay, well, that's all we're going to do for examples of factoring, and hopefully this clarifies some things, and if it hasn't, then you know where to find me. Thanks so much. SanfordFlipMath. Bye.